Go.
Hi, my name is Per Østrin, and this is a presentation of a solution to the problem C, connect the dots, from NWork 2017. So in this problem we were given a 4x4 grid of the numbers 1 to 16, like this one, and what we wanted to do was to draw lines through these dots that connect the dots in order. So starting at 1, going through 2 and 3, going over to 4, going over to 5, 6, 7, 8, and so on. And we wanted to do this using as few turns or as few lines as possible. Okay, so this can be solved effectively by a greedy solution, but it's a kind of tricky greedy solution. So what we're going to do is we're going to keep track of the minimum number of lines needed to get to each point, but in addition to the number of lines needed, we're going to keep track of which range of directions we could be coming to that point from. So the start is, well, we always go from 1 to 2. So from 1 we always have to go towards 2. So there's only one possible direction to go. And when we are at point 2, then we see that the possible directions we could come to 2 from, if we just continue on that single possible direction, we're ending up at 3. So the best thing to do in point 2 is just to continue going upwards. And the same thing, so from point 3, the best direction, the only choice to get to point 3 with a single line is to come going in this direction. But then when we get to point 4, now we kind of have to make a turn, because point 4 is not on this line that we're on. So we're going to have to make a turn, and we can kind of choose when to make the turn. Do we make it directly after point 3, or do we go some distance up and then turn towards point 4? So we get like a rate. If we turn directly at point 3, we're going to hit point 4 in this direction. If we go upwards, you can imagine going upwards all the way to infinity, and then going down again, and then we're effectively going to come down to point 4 in this direction. And any angle in between these two, we can enter point 4. So we can get to point 4 in the shortest possible number of moves in any angle in this range. Okay. And then so we continue this process. So if we could come to point 4 in any of those angles, we can, there are 3 different extremes to consider for how to get to point 5. Either we go there directly from point 4, in which case we get this direction, or we sort of continue along this direction towards infinity and then head back, and then we're going to be going in this direction, or we continue down and then go up, and then we'll get this direction. So all the points in between here are possible. So this one was in the middle, it doesn't really matter. All the points in this range now are possible directions we could be going out of point 5 if we went to point 5 in the minimum number of moves. So then we continue like with point 6. Either we go from point 5 directly, or we go this diagonal down. It's something like this if we go back, or we go up and then down, get something like this. So this thing in the middle disappeared. So we can get to point 6 in any of these directions. And now we get to point 7, where things get interesting, because point 7 is, the direction of point 7 from point 6 is inside this range of possible directions we could be coming in. And that means that now we should make a greedy choice of just, come on, let's take this, let's make sure that we came in exactly this direction so that we got point 7 with the same line without having to make a turn. So then we get, the range of possible directions is now a single direction, and point 8 was in the same direction, so that's going to continue like that. So then we continue this process for the remaining points. So every time the next point is in the range of possible directions from our current point, then we don't have to make a turn, we don't have to create a new line, then we save one. And every other point we're going to, if if the point is outside the range of possible direction, like here, going from 5 to 6, the possible range was in this direction, but 6 is outside, then we have to make a turn to get to 6. So, and basically that's it. You simulate this process all the way, and you count like how many times did I manage to save a turn because the new thing was in the right direction. So there's one extra tricky thing too, which is that so far I kind of assumed that it was allowed to go all the way up to infinity and go back, so that here you can go actually straight down, which would have made a big difference. Like if number 5 was here, then like going up to infinity, 1, 2, 3, up to infinity, and then going back down 4, 5 would have been a way of getting to 5 in just 2 lines. But this is not possible because it's not possible to go to infinity. So you have to keep track which of these endpoints sort of are assuming you can go to infinity and which ones are actually possible to reach. So some of these ranges will be including one endpoint but excluding the other. And so here, like, this one is not including this endpoint, but this endpoint is fine because it's just going to 3 and going that direction. And similarly, this one endpoint was, we couldn't really get exactly that. We could get arbitrarily close to that angle, but we couldn't get it. So it's a half open interval of angles. So you basically do this, keep track of these intervals of angles and like which endpoints are open and which are closed, and then you basically simulate the process, 16 steps.